Assalamualaikum. My name is Muhammad Nazri bin Mazlan, metric number AN180199. So today I will present my final year project. The topic is investigation of properties on crude palm oil, waste cooking oil and Jatropha oil with standard diesel. So my supervisor is Mr. Muhammad Asri bin Azizul and my co-supervisor is TS Dr. Mat Norizam bin Muhammad Ja'ad. So this is the content for my presentation today. Today, petroleum crude oil is in shortly supply. The use of biodiesel is one of the most best measures to overcome this problem. So biodiesel can be produced from stretched vegetable oil, animal oil, fats, tallow, and waste cooking oil. The process used to convert this oil to biodiesel is called transesterification. Malaysia is known as the world's second largest crude palm oil producer and exporter. Malaysia's oil palm industry has grown tremendously and is now a key economic sector. Waste cooking oil biodiesel manufacturing is economical and ecological friendly since it recycles used cooking oil and produces renewable energy with less pollution. It reduces the cost of waste management while also substituting for some petrochemical oil imports. Then, another type of biodiesel is called Jatropha. Jatropha has been identified as a potential energy crop, allowing countries to develop their local alternative to fossil fuel with many numerous advantages in Asia and Africa, which are largely net importers of vegetable oil. Jatropha can produce more oil than soya, peanuts, and sunflower. After minimal adjustment, the treated oil can be utilized straight in diesel engine or blended with normal diesel. So move to the research background too. As biodiesel production increases in the market, it needs to be stored before it can be sold to consumers. When biodiesel is stored for a long time, it experiences degradation process. This situation will affect the fuel properties. According to Earl Christensen, oxygen exposure, light exposure, temperature, and contamination from metal may lead to the fuel quality degradation. Furthermore, because of the oxygen enhancement caused by the storage technique and moisture exposure, a rise in the number of oxygen will enhance additional oxidation of CO exhaust emission during combustion process. Because of the oxygenated nature of palm oil and the lower quantity of carbon in palm biodiesel blend, it appears that high oxygen level is also a factor to be considered. High value of density and viscosity are tend to reduce the atomization of fuel injector system. So next, we move to the problem statement. For the first problem statement is long-term storage of biodiesel might result in increasing deterioration of fuel characteristic, which can jeopardize fuel quality. So the change in properties may affect the engine condition and its performance. Next, the objective. So the first objective is to investigate the properties change due to the storage of crude palm oil, waste cooking oil, Jatropha and standard diesel fuel. Second, to study the effect of change in fuel properties on engine condition and its performance. So for the literature review, the first article is Impact of Water Content on Microbial Growth in Brazilian Biodiesel During Simulated Storage. So the finding is the presence of moisture has a considerable impact on the characteristic of fuel and can speed up ester oxidative degradation by increasing their hydrolysis capability, lowering the stored fuel quality. Furthermore, the presence of water encourages the growth of microbes, which can impair oxidation stability and catalyze biodiesel hydrolysis events, altering the acidity of the fuel. So for the summary, microbial growth encourages high water content, as predicted. and a starting condition of 200 ppm of water was adequate to launch microbial development in all contamination tests. The fungus community discovered in the biodiesel samples was influenced by the amount of water and mineral available. So for the second article is the production and comparison of fuel properties on biodiesel with alternative fuel. So biodiesel fuel has higher water solubility than diesel fuel. All of the variables mentioned above might expedite biodiesel degradation. So for the summary of this article, the acid value and water content of blended biodiesel kept in ventilated location increased dramatically. And for the third article is long-term storage stability of biodiesel and biodiesel blend. So the finding is oxygen exposure, metal contamination, and other radical initiation, as well as moisture exposure, exposure to light and heat might all lead to fuel degradation. Because acid generation was only observed after the loss of Ranciman induction time, the value of acid in the blend increased only when the peroxide value increased. So for the summary, the standard ASTM D6751 and D7467 appendices already encourage measuring acid and insoluble material development during storage on a regular basis, but this finding show that integrating Ranciman induction time as part of monitoring program might offer an early indicator of fuel deterioration. So the Ranciman technique is a speed up aging test. And for the fourth article is the effect of storage duration on biodiesel properties derived from waste cooking oil. So the finding is increased storage time at room temperature has a strong impact on flash point rate decreases, especially when the waste cooking oil blending ratio is high. So the behavior linked to the effect of a longer storage duration and a higher storage temperature on the oxidation process of waste cooking oil biodiesel. So for the summary, the rising of storage time of biodiesel obtained from waste cooking oil affects the increasing of density, kinematic, viscosity, acid value, and water content more clearly under outside temperature, according to the general trend of biodiesel waste cooking oil characteristic rate. Nevertheless, the flash point number reduced under both conditions, particularly when the temperature was outside. So for the last article is storage degradation of palm-derived biodiesel and its effect on chemical properties and engine performance. So for the finding, the acidity of biodiesel rose in lockstep with peroxide level. Furthermore, biodiesel made from palm olein had greater acid value and increased quicker than biodiesel made from palm stearin. Biodiesel density grew in the same way that peroxide level did with storage duration. As a result, the formation of peroxide distrite might be attributed to an increase in molecule of damaged biodiesel. The creation of bigger molecule in biodiesel is also indicated by a rise in viscosity at the molecular level. The viscosity of both types of biodiesel decreased continuously for the first 3 months before gradually increasing after that, showing that over a 6-month period. For the summary of this article, the longer the biodiesel was stored, the more oxidative reaction took place at the double bond of the biodiesel molecules, as seen by the decrease in iodine value and viscosity, as well as the rise in peroxide and acid value. This reaction formed shorter hydroperoxide molecules, resulting in lower heating value and higher fuel density. Next, move to the methodology of this experiment. So basically, it has 3 stages. So for the stage 1 is collecting information from past researcher and come up with literature review. Then defining the objective and scope of the study. For the stage 2 is the blending process. The first thing in the blending process is I need to prepare the equipment first, and then in the blending process, the thing that must be considered is the ratio or percentage of alternative fuel blend with diesel, and then the blending temperature, the blending speed, and the blending time. So for the stage 3 is the fuel storage condition, fuel properties testing, and analysis. So in the fuel storage condition, the fuel was stored in a closed glass container at the ambient temperature in duration of 10 weeks. So after that, I use the equipment for the properties test, and then continue to the graph plotting, and lastly the discussion. So next is the equipment used for the properties test. So the first equipment is Mittler Toledo diamond scale. So basically it is used to measure the density. This equipment is based on ASTM standard D1217. And next, the Viscolite 700. So Viscolite 700 is used to measure the fuel viscosity. It is easy to use. Just dip the tip of Viscolite, and after that, the result will come out at the digital number. So this Viscolite is refer based on standard EN ISO 31004. And then the volumetric Karl-Fischer titrators. So basically, volumetric Karl-Fischer titrators used to determine the water content. So it is based on standard EN 12937. Then the titration process. The titration process is used to measure the acid value. So acid value formula was used to determine the final acid value. So this is based on standard EN 14104. And lastly, the Penske-Martens PMA4. It is used to determine the flash point. So basically, Penske-Martens PMA4 is a closed cup tester. So it only refers to the EN ISO 2719. And next, for the result and discussion, as we can see in the slide, there is the graph on effect of storage time on fuel water content. So basically, as shown in the graph, standard diesel is more stable compared to another biodiesel. This is may be due to the more oxygen content on the biodiesel. And then the proportion of water in fuel will alter depending on how long it's stored. So the huge quantity of water content will lead to bad effects towards the engine. And lastly, the occurrence of biological growth in the tank may influence to the corrosion, and formation of impurities could reduce the performance of fuel injection. And then this is the effects of water content on other properties. Overall, the storage of fuel will affect the kinematic viscosity value. Most of the fuel viscosity increase with the increasing number of water content. So this situation will give a negative impact on the engine performance. As the number of viscosity increase, it tends to reduce the atomization characteristic in the fuel injector. A high viscosity fuel may cause clogging problem towards fuel injector system. Based on American standard ASTM D445 standard, the limit for biodiesel kinematic viscosity is from 1.9 centipoise to 6 centipoise. The In conclusion, to low and high viscosity value may give a negative impact toward the engine. And then the fuel density. A material density is calculated and defined from a mass per unit volume. Basically, the density of fuel will rise in the molecular weight of the fuel molecule rise. Based on the graph, the density of all fuel increase when the water content percentage rise. So the interaction of peroxide during the breakdown of ester is primarily responsible for the rise in methyl ester density. Density of a fuel plays an important role in ensuring the performance of an engine. Rise in biodiesel density will be crucial aspect since they will give negative impact toward the fuel injection system. And then the flashpoint. Variation of fuel flashpoint and its water content for standard diesel, crude palm oil, waste cooking oil, and Jatropha what's shown in the graph. So the flashpoint is the temperature below which the vapor above liquid burn when the ignition source set on. So based on the graph shown, the flash point of standard diesel was stable at 77 degrees Celsius and water content did not change significantly. Generally, the flash point value for biodiesel is higher than standard diesel. Flash point value were important to determine the flammability and it became as a safety indicator for fuel storage and transportation. Low value of flash point may influence knocking problem toward the engine. And lastly, the acid value. The acidity rating of a fuel is a measurement of how much acidic compounds are present. From the graph, it shown that only standard diesel had smooth increment of acid from 0.17 mg KOH per gram and it stopped at 0.18 mg KOH per gram. Generally, higher water content will give higher effect in acid value due to the oxygen concentration in biodiesel. Diesel is more stable without oxidation process than biodiesel. So hydroperoxide generated during oxidative degradation can undergo a variety of intricate secondary reactions, such as breaking into more active aldehydes, which subsequently oxidize into acid, causing the rising in acid value. So the high value of acid may cause negative impact towards the engine fuel system, such as corrosion. The standard maximum permitted limit of acid value for biodiesel is roughly around 0.5 mg KOH per gram based on standard ASTM D6751. And then for the conclusion, the standard diesel fuel was more stable than biodiesel, while Jatropha biodiesel JO15 was most unstable fuel between all biodiesel. So the storage properties of biodiesel blends have a significant impact, especially at large blending ratio. The increasing of storage time for all blending ratio of biodiesel and standard diesel are resulting in the rising of the water content. The increasing of water content is found to increase the kinematic viscosity, fuel density, and the acid value. Nevertheless, when the water content value of biodiesel increase, their flash point is tending to decrease. And lastly, the change in fuel properties may affect the performance and condition of the engine. So this is reference for this presentation, and that's all from me. Thank you for your time.